absolute. And I know it didn't tell me to find it, but we're just going to discuss it a little bit. And this one right here is only a relative because other values are going to go below it. So this one again is not absolute because other values go below. And some of you may say, well, how do you know it keeps going? How do you know it doesn't turn back up and then that's your very, very minimum value? Well, if it would have turned back up, we would have found another critical value, and we didn't. Plus, we can use some other skills and say, hey, this is a cubic. Cubics have 2 humps. You guys know that song? Alice the camel has 2 humps. Okay, anyway. So I only have 2 humps going on, and that would be correct for a cubic. All right, so it wants the relative extrema. So I have at 0 something, which I'm going to have to go find, and at 4 something, which I need to go find. So plugging in 0 into f of x, so up here I'm at 0, 15. And we know that that is a relative max. Oh gosh, let's plug in 4. I'm going to cheat. I'm going to use my calculator. Okay, you can't do this on the test. You have to do the math by yourself. But let's see, 4 cubed minus 6 times 4 squared plus 15. So this would be at 4, negative 17. And that is a relative min. Okay, so I would pause right here and just give yourself a little bit of a summary before going on to make sure you have down everything that we just discussed from this problem. And I would pause again and see if you can't identify the critical numbers where the function is increasing, decreasing, and the relative extrema on this one by yourself. And then unpause, at certain times, see if you get the derivative right or different things, and check yourself as you go, but don't just write what I write. Low, C high, minus high, C low, all over, low, low, oil, woohoo, alright, 2x squared, plus 2x, minus 2x, and then minus 2, minus x squared, plus 2x, minus 1, squared, plus 2x, minus 3, and I know that's factorable, so I'm going to go ahead and factor it, since I'm going to be solving for all kinds of things. So that would be x plus 3 and x minus 1. Okay, so my critical numbers are going to be where f prime of x equals 0. So that would be at negative 3, x equals negative 3 and 1, and where f prime of x doesn't exist, so it would be at negative 1, and any endpoints which I don't have, but I wouldn't include them for relative anyway. So here are my critical numbers. Now, note in my critical numbers, this guy right here. I know I have a vertical asymptote going on at x equals negative 1. And we can kind of see this is x minus 1 quantity squared. So it doesn't cancel out. It's not a hole. It is a vertical asymptote. So when I go make my graph for my f prime of x and my f of x going on, this guy is a complete vertical asymptote. So it can't be a relative max or min, because it's not defined in my original function. But it can still determine where a graph could change from increasing to decreasing. So it's still a critical number. Okay, let's get some values down here now. Maybe like, what, -5, -2, 0, 2. So go plug those in and see if you get positives or negatives for f prime of x. So let's see, f prime of -5. I plug in here, I'm going to get a negative times a negative, and the denominator is always positive, so that would be positive. So that tells me that f of x is increasing. Let's try -2. -2 is going to be, plugging it in, positive times a negative, and again that denominator is always positive, it's squared, which is a negative. So f of x now is decreasing. Oh, what did we just find? We just found at -3 some value, I'm going to have a relative max. And we can go plug in the value. But let's go ahead and finish up this part. Okay, let's try 0. F prime of 0, that's going to be a positive times a negative, and that's all over positive. So this is still decreasing. And let's plug in 2. That's going to be a positive times a positive, all over positive. So this is positive, so this guy's increasing. Awesome, so I found that at 1 something, which we can go find here in a second, I'm going to have a relative min. Alright, so let's go fill in those values really quick. And to do that, we're up here at f of x, so let's plug them into our function up here. And again, I'm just going to do this real quick on the calculator. It's probably faster actually to do it by hand. But I'm just going to say -3, store for x, and then I can just type it in. I'll show you what I'm doing. I'm going to say -3, store for x, and then I can write my function exactly as is, since I'm going to be putting different values in. And here I see I get out -8. And then when I plug in my 1, all I have to do is 1, store for x, and then I can go up and get that function, and I get out 0. Alright, so let's put all of this together, what we found. We found that f of x is increasing from -infinity until -3, this part, and then over here on this part, from 1 to infinity. And I found that it's going to be decreasing from -3 until -1, and then -1 until 1. Make sure you do not include the -1, so that is not the same as -3 to 1, because you have an asymptote there, so you cannot include that. And then we already found we have a relative max at -3, -8, and we have a relative min at 1, 0. Let's see how we did with our graph. I'm going to go y equals, let me go, let's see, x squared minus 2x plus 1 over x plus 1. and I'm just going to zoom standard. So here I can see that I am increasing until that value. Oops, second calc max. Let me go a little bit further. I couldn't hardly see with the words. Okay, so here I found that relative max was -3, -8, and I'm increasing until then, and then I'm decreasing after them, but I keep decreasing and I have that vertical asymptote, and then here I have my relative min at 1, 0. Pretty cool, huh? Ooh, I also have a slant asymptote, which we will get into. And I know that because the degree of the numerator is bigger by 1. Okay, only when it's the degree is bigger by 1. Alright, see what you can do on this next one. And then when you're ready, unpause and check. So I had to do my chain rule. I'm going to rewrite it a little bit. So here I have a critical number of 1 where the first derivative doesn't exist, but I don't have any where it's 0, and I definitely don't have any endpoints going on. So I only have one critical number. Oops, that's f prime of x. Come on, DeRose. That's f of x. Is 1 an asymptote, or a whole, or is it defined on f of x? Well, up here on f of x, you can plug in 1 and you get out 0, so it is fine. It's only undefined in the first derivative. So let's see, a value before, a value after. So let's go plug those in. So f prime of 0. So plug in 0. What do you notice you're always doing? You're always squaring whatever you get and then taking the cube root. So no matter what you plug in, it's always positive for any value. So I know I have positive and positive, which means I am increasing and increasing. Ay, 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 what is that? Okay, so let's see. F of x is going to be increasing from -infinity until 1, and then 1 to infinity. So what does that make 1? I don't have any relative max or min, so no relative extrema. So what do I have? Well, later we'll find out. This is a point of inflection because we're going to do the second derivative, and we'll see that that actually will change signs and we'll have a point of inflection. So let's just kind of look at that graph really quick. X minus 1 raised to the 1/3. So here you can see my critical number was 1,